Okay, I'm talking about the StreamYard. We were not live before.
Yeah, yeah, I'm live now on stream.
So
So it just it has started.
let
Okay.
me tell
So
you
you say
how
I
to
should mute. So I should mute this. I should mute this one, Abi. This
yes, yes, yes.
the one on Flink.
Yeah, yes.
Yeah. Okay, it's even muted. It's even muted.
Put me for backstage.
Okay.
Let me go. I'm going backstage now. I'm
You are
going
doing what?
backstage. I'm going backstage, backstage.
Okay, okay, okay. All right now.
Send the send the classroom link from Think. You'll see the link on your tab. Just
Yeah.
send the
Okay, 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 okay. That one that I muted. That one that I
eh?
muted, Abi. That one that I
Yes,
muted.
yes, yes, yes.
So should I say where should I put it? Should I put it
Just
here?
yeah, put it here, put it here.
Should I put it?
Put it here, put it here.
Are you
I will
sure you'll be able
screenshot
to copy it?
I'll screenshot it and extract it.
Okay. Or I put it on WhatsApp. I've sent it to you on WhatsApp too. Hello, 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 can you hear me? Can I paste can I paste that link on my WhatsApp group or my WhatsApp status? Eh? I know they hear you. Okay. You don't type raise your hand, say thumb up if you are saying yes. Is it yes? Because I know they hear you.
Yes, yes,
Like
yes, yes,
my
yes,
phone, my WhatsApp.
yes, yes,
Yes,
yes,
Abi.
yes.
Okay, okay,
Yes,
okay, okay.
yes. Okay.
So how many people do we have now? Okay, so how many people are here? Let me check. I'm the only one alive. That's crazy.
Ẹ̀yin ẹ̀ jáde o, ẹ gbọ́, Tájídára. Alpha Victor.
Happiness. Say you want to know that you see. Say you want to know what I know.
Alpha.
No, no. Start. Okay.
Just teach as if don't care about anybody that just see here now. So just teach as if it's for a YouTube recording.
Okay. So, but you dey hear me?
Yeah.
Okay. So let me just inform someone that I want to start a class so that they won't disturb me.
Okay.
So Ah, ẹ jọ ṣé mo ti bẹ̀rẹ̀ kíláàsì yẹn ni ṣé mo lè pè yín later?
Okay, wà ní online class.
Yes, sir. Ṣé mo lè ń kéde?
Sorry.
Yes, sir. Yes, sir. Alpha. Are we ready? Ṣé èdè yẹn mi? How far now? Because I went to drop my phone. I want to drop my phone where there's network. Because if it's here now, it's just fluctuating. Like I want to drop my phone very far. I say I'm not tired today, wallahi. But I guess now because it's the first time. So shey you go edit this one back, maybe we start afresh. Shey make we start afresh, abi how we wan run am? Omo. Me I no hear you sha. Shey you dey hear me? Like I'm saying that should we start afresh? Maybe I should call you on WhatsApp call so you can answer me. Reply me on WhatsApp. Omo, to love am. Abeg wait o, I wan stay outside new. Go wait. Sir, ah, bó ṣe wà láti bó ṣe wà bẹ́ẹ̀ olúwa ni. Ọ̀nà. Hello. I think I'm okay now. I think the network is okay. Abi? So should I restart the stuff? Because we cannot use this one. Oh. You are going to edit it. Or how? Restart, Abi. My God, I know they hear you.
I'll edit it. Alright. I'll cut it. I'll cut the first part.
Okay, oh yeah. So nobody's in this class like this. So, okay. Let me open my paint. Okay, but there's no need of paint yet. Do I need paint? But let me try open it in case I want to write something. Okay. Are we good? Yeah, let's start. Hello, good everyone. How are you doing? Welcome to this wonderful program, which is learning how to think and not just to pass examination. Today we'll be dealing with a lot of things, and which will be definitely strange to some people. To be strange to some people, and it will be relatable to some people because some people are already dwelling in this kind of knowledge experience. But to a lot of people, they will be strange to this kind of enlightenment, this kind of learning. So for today, okay, let me start by introducing myself. So I'm Opawumi Victor by name. People call me Softvic. I'm Softvic, and I am a computer engineering graduate of University of Ilorin. So I'll be our tutor for today, which is learn how to think. So I'm not just passing exam alone, but this is mathematics focused. And I before we start anything on this wonderful program, I say I'm having my first slide displayed. And I'm not starting from there. I would like to open our mind to a lot of things because over the years, at least for I think I have like more than 5 years, 4 to 5 years of teaching experience. I have been teaching for a while now. Usually, I've taught mathematics, physics. I've taught a lot of science subjects, and I've also taught programming because I'm also a software developer. I've taught how to develop websites before. I've taught a lot of people, and I've observed a lot of things from people, from students, and most of the things I observe, I notice that they are normal, they are regular patterns that are coming up from different people. They are coming up from everybody that I've taught. So one of those things is just having the eagerness to pass exams. Because if I just bring a question, now and I say, everybody, what is 2x plus 2 equals to 4? Find x. Some people's mindset is not, just to look for a formula. Or if I draw a right angle triangle now, and I ask us to find one of the sides and giving us two sides. I'm sure everybody here that has mathematics enlightened before would know that you're supposed to apply a formula for that. So we are definitely coming to that step by step, as I have a lot of things. I have a lot of things arranged for us in my slide prepared. So let me. I would like to start by telling us about a man called um, Carl Friedrich Gauss. Yeah, I'm sure a lot of us would have heard about this man. He's definitely he was a scientist. So before I talk about him, I want you to prepare. I want you to know that you are in the best place, where you can gain knowledge, where you can actually learn what is really applicable in the real world. Because this is not a class that will make you know how to cram formulas, that will make you know how to do a lot of things, how to just show. This is not for show, it's just for you. You think more in this class just um than just cramming. You think more. You won't even cram at the end of the day. By the time you understand what this program is all about, you will definitely appreciate this program more than you expected. So now this man, one of the story, I called him Gauss. Yes, a lot of people will be familiar with him, Carl Friedrich Gauss. Gauss was, when he was younger, his teacher in school gave all of them in the classes an assignment. He was younger, he gave them it's not an assignment, a classwork. The teacher asked all of them to add up numbers from 1 to 100. He asked all of them to add numbers from 1 to 100. You know, the funny thing is that most people, even apart from the students then, even students now will do the same thing most people did then. You have to add the numbers one by one, 1 plus 2, then 2 plus 1 plus 2, then 2 plus 3, then that 3 plus that 3. You have to be adding one by one like that. But you know, the funniest thing is that this guy was actually different. He could have done like others, but he was calm and observed. So one of the things I I want us to know today, because there are a lot of points I'll be bringing out in making someone to think very well. What this program is to make you be at the end of the day is to make you a dangerous thinker. I know a lot of people will be like, what am I trying to say now? A dangerous thinker. I mean, and repeat again, dangerous thinker. Who is actually a dangerous thinker? A dangerous thinker is someone that actually does not follow regular, um, regular way, regular belief in which people think. Yes. So God was a dangerous thinker because he was so observant. He could, I'm sure one of the problems he would have thought of was the stress. He would have thought of the stress. He would have thought of the time it would take him to add up his number would be so much. So he had to think of an alternative that will substitute for that. You have to think of an alternative because you can't use you will definitely especially for some of us that are lazy, if not for the thank God for the use of calculators now. I'm sure if there's no calculators, a lot of us will fail in school. I'm sorry to say it might not be general, but I'm so sure that a lot of us will fail in school if there are no use of calculator. But it is not too late, no matter how old, how small you are. It is not too late for you to learn because everybody learn. It is good for us to learn when we observe that we have not been learning. It is good to learn at that effect. Yeah, one of the things that is good for a man is that when he observe his mistakes, he should immediately correct it. So this is an avenue for you to start thinking like a real thinker. Yeah, a real thinker. So now don't let me divert. So what he had to do was he actually observed. He had to arrange the numbers. He arranged one and removed. He brought the first number. For instance, okay, let's start from that. So let me present. Let me share my screen. This is actually a story, and I didn't plan to actually present anything, but I wanted us to understand what the guy actually did. So sorry. Mommy. Okay. Okay. Just we can. My screen is not showing. Okay. Sorry. Okay. All right. So now, um, okay. So let me show us what I did. So now, if you are to count numbers, you count from 1 to 100. So you have to pick the first and the last. Pick the second, then the next to the last. You understand? So for instance, you have to pick one. You have to pick one and you have to observe 1 and 100. 1 and 100. Let me say 1 and 100. Don't let me say add now. 1 and 100. You observe 1 and 100. Then you also observe the next one is 2 and 99. He was thinking. He had not even thought of how to solve it. He was just observing. So one of the things that makes you a very good thinker is to observe. You need to learn how to observe very well. Because if you don't observe, you cannot even think of a solution. You need to first observe. That's why when a lot of us face problems, we give up easily. And why we don't know that it's a period for us to observe. So now for let me continue. Let me show one more. You have to do. Let's make it 4 so we can get it. So you don't say this is juju. Say 98. He observed 4. Okay. Let's say he still wants to confirm very well. He observed 4 and 97 now. Can you see as this one is increasing, this one is decreasing? You observe those numbers and you notice that now after observation, you now notice something. So I want you to be noticing some things now, because you cannot. There's no how you will observe something and you not notice anything. Okay, my network was gone for a while. I don't know. Can we hear me? Okay. Yeah. So now one of the things I talked about observation, and I said, quote me again. I said observation will make you notice. So I said there's no how you will not notice anything. So even if you don't notice anything, you have noticed something. The fact that you notice that you don't notice anything, you have noticed something. I don't know if you get what I'm saying. If the fact that you know that I think I didn't, there's nothing I noticed here, so it's still a process of observation. Do you understand? So whether you notice or you did not notice anything, whether you see or you did not see anything, you have still noticed. You have noticed that you did not see anything. Do you understand? So you have to observe. So you observe that these two numbers, numbers are arranged 1 and 100, 2 and 99, 3 and 98. I'm sure they will have done a lot of basic mathematical operations in mathematics, and he had to think of addition, subtraction, multiplication. The first thing he thought was addition. He had to add all those numbers. If you add all those numbers, for instance, if you say 1 plus 100 will give you 101. 101. Sorry, let me draw this. So we give you 101. We give you 101. Then for this one, okay, sorry. Okay, then for this one, if you say 2 plus 99, we give you 101 too. That's if you are noticing something. If you are noticing something, you can just write in the comment section by telling me you are noticing, by telling me what you are noticing. So you have what 3 plus 3 plus 98 is equals to 1012. And also lastly, you see 4 plus 97 will also be equals to 101. So that's enough of one of the things is that you should know is that even if you did not get anything, the fact that you notice, even if you not get the answer, the fact that you noticed something unique is enough for you. Even is enough for you to push. I'm sure at this point he wouldn't have gotten the answer, but he knew that he's moving towards the way. Do you understand? So in this stage of thinking logically, in this stage of thinking dangerously, you don't give up. I'm a Christian. Sorry for using this word. I want to use realm. Don't let Christians will understand what I'm saying, but I want to say in this realm of thinking dangerously. I'm just joking actually. So, but what I mean is that in this aspect of thinking dangerously, we don't give up when we notice something, because once you notice something, you don't have to go in a waste. You have to make use of it. So now he has noticed that a addition of these numbers will give him 101 of all these numbers. So he thought of it that he paired these two numbers. He paired all these numbers because if you have to do all these numbers and don't make them repeat twice, all of them you have to count these numbers in pairs like this: 100, 299, 398, 497, 596. You have to count all of them. All of them will be 50 if you count all of them, because he didn't actually count them, he didn't write them down. Because many of you will be like, what's the point of now writing it down? What's the difference between him and other people? That no, he didn't do that. What he just did, in fact, it's just for an explanation. That's why I had to write this theory. When you have two or three repeating patterns, it's enough for you to believe that that's how all of them will be. That's why, um even if it's not like that. So sorry sorry for the distraction. If it's not like that, he knows that it's actually along the way. So now he observed that they are in pairs. Those numbers are in pairs, and if you have to count them, since 1 to 100 is 100, so he knew that it would be 50. All of them will be 50. 100, 299, everything is in 50, because 1 to 100 is 100. So that's like 100 divided by 2, which will give us 50. So um if you have one to if you have 50 numbers, if you have 50 numbers in pairs, okay, let me pause. Sorry. You have to edit this part because it seems they want to use this place that I am. They hear me, Samuel, they hear me. Samuel say they hear me. Okay, ṣá ibi lẹ̀bẹ̀ lomi. Wọ́n ṣe nǹkan lọ. Ní ẹjẹ́ yanjú ara mi. Ọ̀nbọ̀. Ṣé ibi bí lẹ̀bẹ̀ tó ti mú? Okay, máa kúrò lókè. Àyè ò ní ìsókè fún àga tèmi. Okay. Network ló gbé mi wá bí o, because mo lọ ọ̀dọ̀. Mo ń bọ̀. Kí lẹ sọ̀tà? Mo ń bọ̀. Ó fẹ́ jábọ́ ni, mo ní láti ṣe dáadáa. Samuel, abeg, no vex. The next class will definitely not be like this. See, will definitely, because I've seen all the challenge now. I know how to amend those things, because I can't even use the head the next time, and I'll have to stay at my place. So I was thinking of this place would be better, but this place is not. So yeah, so let me. Show. Is it a good background? Is it okay? Okay. So now, so I was talking about, okay, these numbers are in pairs. These numbers are in pairs, and they will sum up to um 50 if you have to count them. Logically, you don't need to count them because you know that 1 to 100 is 100 divided by 2 because they're in pairs. That's 50. You just get to use another mathematical operation, which is multiplication. So you need that the two things you noticed was the two numbers you noticed with logical reasoning was 101 and 50. So you just have to multiply 101 and 50. So multiplication of 101, 101, 101 times 50. 101 times 101 times 50 will give us what? Will give us what? That will save a lot of time. That will save it. It's because I have to explain. That's why majority of us, that's why it took me a lot of time because I needed to explain. That's 5,050. 5,050. 5,050 is actually the answer to this. So it saved a lot of time of adding those numbers one by one. It saved a lot of time. It saved a lot of time, a lot of energy of adding up those numbers. So that's actually a story. I didn't plan to actually jump into explanation of numbers. In fact, I didn't plan to write within this time. I knew I would write something and show us, but I just wanted to understand how the guy was thinking. So there have been logical reasoning for a while, for many years. So, and if we want the same thing, all those scientists that are making things happen, they are not actually different from us in the way we think. Actually, the only things that made us they are made the only things okay the only things that made them different from us is the fact that they were not lazy. Hmm. They were not lazy. What do I mean by they were not lazy? Many of us are actually smart and intelligent, but we are lazy to think. So it's actually the difference was that they were not lazy in their reasoning because what most of us are looking for is actually fast. Actually, it's not actually should I say it's not fast method. And let me say fast method. What majority of us is looking for is fast method. So and the fast method is not like I can't say how will I put it to actually, but what we are looking for is impossible fast method, like unreasonable fast method. You understand? So that's one of the things I I want us to think about. So I want us to think about so let's move on. Let's move on. Let me just present the slides again. Okay. Video coming up. Stop sharing the screen. I'm trying to see where I open the stuff. Okay. Yeah. Sorry. Yeah. So for this slide now, if you look at this slide, now what they made is just a point that I want to pick from this slide. So I'll move to the next slide. They said we do not memorize formula, we build them, and I've talked about them. So let's move to the next slide. So now, yeah, this is anatomy of aha moment. I call it aha moment. You can, if you don't want to stress yourself, I can say anatomy of AHA. a moment. Uh, sorry. So the anatomy of the movement. So now let me explain. I've actually mentioned a lot of things from this slide. If you are actually observant, I've mentioned the trap, I mentioned the struggles, and I've mentioned the discovery from the explanation I made. So now, because at the the trap is actually where, if you are not careful, you can feel you can be overconfident rather. Do you understand? So at that part where you, okay, if you are that's if you are not careful, but the trap is where the confidence actually come from. You understand? So then the struggle is the brain rewiring. That's the struggle. The brain, where you use your brain, where your brain actually works. You understand? That's where the brain rewiring occur. Then the discovery, which is the pattern recognition. You know, I was talking about, I said this is an unusual way. It's an unusual way from normal. It's an unusual way from the way we do things. We do things generally. Do you understand? So in this kind of thinking, what we deal with is pattern recognition. It's not memorization of formulas. It's not memorization of formulas. It's not cramming. Do you understand? So you can see from this is self-explanatory stuff. You can see from the slide I presented. They said intuition fails. You answer the obvious but wrong questions. Do you understand? First breakdown, then listing every possibility becomes impossible. Now, this Rufus was actually made me laugh because I remember in my 500 level, we did a course related to brute force mechanism, and it's one of those aspects that deals with um, that makes you think very well. It's one of those aspects in engineering. So it's this is the stage where you think very well. Then after your brain works, then you discover. Moving on to the um next slide. Okay. Please, Alpha guy. They tell me I want to see the. How will I know if my time is going? Because I don't even know when I started. I don't know. I know you go edit this part. You go try edit this part. So I don't even know. How will I know? How will I know about my time? Okay, I'll continue. Will you drop it in the chat? All right. Thank you. So now moving on to the next slide. So which is this is the sweetest part of logical reasoning. This is the sweetest part of thinking very deep, because we have talked about the hook, because the hook is actually the real world questions that seem simple. Do you understand? You'll be confident you know the answer, but you probably be wrong. Do you understand? That's hook. That's why, I used to tell some students, I have some jam students who tell me they know how to solve question, and at the end of the day, they will miss the question. This is not because they're actually clueless about it. Understand? They are not clueless about it. It's just that what affected them was that they don't understand what hook means. Because majority of exam bodies uses this method. They use hook because this question will seem like it's something that you know, and they will actually put answers. They will put answers of they will put the answers that are wrong. They would actually think the way you would think generally, and they will put the answers there. And at the end of the day, when you pick the answer, you notice that you miss it. Do you understand? So it's hoop. Is hook. So you have to understand the way it works. You have to understand that very well. Then the struggle, I've talked about the struggle, the discovery. Now, after you discover, you can see when I was talking about the gosh, I was talking about gosh the other time. He discovered something and he applied it. So the next one after discovery is the application. That's the new tool that you use. So your new tool is tested against a real Nigerian problem. So yeah, they see the explanation now. They say your river is testing against Nigeria problem from valuable market price to downfall bus route to Lagos architecture. Now that's the application. So application after you discovered, you apply the knowledge. You applied what you've discovered using your brain too. Do you understand? Then the arena, life problems, real computation pace, you raise to answer in chat, correct answers and instant recognition, your classmates learn from you. So what what it now brings about in this kind of reasoning, in this kind of aspect, in this kind of environment of thinking logically, thinking reasonably. So now moving on to the next slide, I think I love this light so much, and I would um I would like to make a quote by one of the um it said I would like to make a quote by one of the scientists because I wrote it down while I was um while I was working on this slide. So I wrote it down. He said he said something. He said, "What would it feel like to ride on a beam of light?" So this is a quote. This is a statement made by Albert Einstein. Einstein was not known for memorizing formulas. He was not known for memorizing formulas. He was known for asking simple but deep questions. You understand? So, and from the statement I made the other time, we said, what would it feel like to ride on a beam of light? And the question is actually leading to relativity because we actually think about the statement logically. You'll be like, how can you ride on a beam of light? It's actually talking about relative. So looking at this aspect. Now, if I'm to ask, if I say for a this is 6, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. For an 8 by 8, got it. For an 8 by 8, this is 8 by 8 because I counted this side. I counted this side. So for an 8 by 8 board that has smaller squares, well, for a chessboard, so let me just say chessboard, how many squares do you think? And I even with what I've said, some people will be like, you have said the answer. For me to even say 8 by 8, I'm sure that's what a lot of us are thinking now. Because I said a chessboard has smaller squares. A chessboard has if you have to count each squares vertically, count each square horizontally, you will think like, okay, if you want to think like a smart person, like now, because I have said that goals will actually not count one by one. A lot of us will want to actually use that method. 8 like this, 8 like this, 8 times 8. I'm sure we'll say 64. Yeah. You can see some people are already thinking 64. So it's not actually 64 because nobody actually says that a square, a square alone is the smaller box alone. Yeah, we have a bigger box. If you have a two, four smaller box, four smaller square can give a square too. Four smaller box, you can say 8 smaller box can give a square too. So now you can see from this slide I presented now, you can see that if you look at it, 1 times, you can see if you look at 1, sorry, my CCP. If you look at, oh God, if you look at this and this, you will say, in terms of size, for small, for 1 square, you have 1 times 1, which you have, look at it, you have 2 times 2, you have 3 by 3. Do you understand? 3 by 3. So for 1 by 1, what I mean by 1 by 1, this is simple. What I mean by 1 by 1 is that if you are counting each square 1 by 1, that's what I mean. No. If you are counting each square 2 by 2, for instance, this one you take it as 1, this one you take it as 1. If you are counting it, what you will get is 49. If you are counting, so if you are counting the square 3, if you are counting it 3 by 3, you do that until it is 8 by 8. You count the square 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6, 7 by 7, then 8 by 8. So after you count it like that, you observe that you have many squares more than, because what comes to our thinking first when we ask this kind of question is that you only count the smaller squares, which is 1 1. Do you understand? We don't know that there are more other squares in the chessboard. So for this chessboard now, you have, if you sum up all these 1 by 1, 2 by 2, 3 by 3, so you don't even need to do stress yourself. 1 square plus 2 square plus 3 square plus 4 square plus 5 square. If you add up all those numbers, they will give you 204. So you will have what, 204 chessboard. I don't know if you get what I'm saying. I don't know if are you getting it? Hello? Is anybody hearing me? My network is gone. Okay. So now let me move very fast. Because of slide. Okay. So now look at it. You know, in the beginning of the class, I was talking about this. I talked about a triangle. I spoke about a triangle, and I gave an illustration of it having 2 sides known and 1 side unknown. And I said, what will come to our mind if I ask us to find the 3rd side? What will come to our mind? I will follow it. And I'm sure what majority of us were thinking was Pythagoras theorem. Yes, majority of us are familiar, or we are familiar with it because we know that this is how we solve it. It just have a specific formula. Yeah. So, but now, what the problem is not actually you knowing. It's not actually you knowing the square. It's not actually knowing the formula. That's not the problem. The problem is you knowing how the formula is being formed. You know, there are some things that if you actually know formulas, if you actually know how formulas is being originated, I don't know if it has happened to many of us. There are sometimes that when I get to exam, I could remember while I was in is it undergrad level or secondary school, I don't know. Many times when I forget formulas, but I know how the formulas is being formed, I don't get panicked. I don't get panic in exam hall because I know that I will find my way around it. I will actually prove it. Then when I prove it, I can now do the application. So there's no need in me cramming anything. And that, it makes my work easier. It makes my work easier and even faster. And clear. there are clarities in what I'm doing, because at the end of the day, if I drop what I crammed, the formula I crammed, and I substitute, I might make mistakes. Yeah, I might make mistakes because I have crammed it, and we are humans, we are prone to errors. On um in exam environment, exam situation, we are, most of us are. That's why you cannot see. I used to tell people, it will be hard for students to get 400 over 400 in jam. Why? It's very hard to get 400 over 400, because in it, whether the person is smart or not, I'm still sure almost every Nigerian still cram. I'm so sure almost every Nigerian. The reason why there are small errors in what we do is that when we apply all those cramming stuff, I'm not saying, don't quote me, don't quote me wrong. There are times that cramming will be useful for you, but let me be frank with you. Cramming will definitely not help you move far in this real world application, because if you are looking at it, this is mathematics based, and I'm sure, because this program uh is meant for people of 10 to 17 years. So now, if you are between 10 to 17 years here, the program is not actually to make you know how to quickly know a lot of formulas in mathematics. No, it's to allow you to think, because after this stage, you will move to the next phase of life where you have to be applying a lot, where you have to apply what you have learned so far. So now, if what you have learned so far is about cramming, if you had crammed so far, it will be very hard for you to apply it in the real world. It's very hard for you to apply it. So that's why this stage is very, very important. So now look at it. To be fast, I said, because I want to move very fast actually. Because we have, maybe in our next class we'll do a lot of justice to some things here. So now before the formula, now look at, before the formula, a picture. The area of a square on the hypotenuse equals to the sum of the squares of the other two sides. We all know that. Now, I said this isn't a formula to memorize. It is a relationship between areas. One you can see. Is it now? Look at it now. From here now, from this second soft, this second side, it means that, look at it. If you have to draw, this is a triangle actually. This is a triangle, and why it's being divided into two. You have 30 here, you have 40 here. Definitely you have 30 here, you have 40 here. Look, I don't know if you are getting me. This is it. You have, if you look at it very well, I said this is 40 here, this is 30 here. Definitely this will be 40, this will be 30. If you have to look at it, the only part that has a single line is the hypotenuse. And if you are to look at it, if you are dealing, the hypotenuse for this one is also the same thing for this one, but separately if they are to divide it. So now let hear this problem. The school compound in Ibadan is a rectangle 40 by 30. The school wants to paint a diagonal path from one corner to the opposite. How long is the path? See, let me tell you, some of us, we know some things, but we don't know how to apply them in the real world. I was telling someone, let me quickly use this. I was telling someone, we were working together, we were trekking. So the way the route was like, look at my hand now. Maybe you will get it. The way this is where we are going. I'm here. Look at my hand. I'm here, and we are going to this side. We are going to this side. So this person was like, "Let's go like this, then we'll come like this." Then I was like, "Why don't we pass the hypotenuse? Why don't you pass the hypotenuse?" The person was like, "What's this hypotenuse? What's hypotenuse?" Because it will save us time. If you have to go through the opposite first, then you go to the adjacent before you now reach that angle. Why not passing the hypotenuse trace? Yes, sir. Why not going straight where you don't have to curve? When you don't have to go straight then curve. That will save you a lot of time. That's one of the application of Pythagoras theorem. You understand? So the student here, the question here was like, is like how long is the path that they will do? So basically, you just need to apply Pythagoras theorem because you know you have to divide. Once you divide the square into two, you have a right angle triangle, and from the right angle triangle, you know the two sides. Just apply your Pythagoras theorem that you know. You get what 50 meter. Very easy. That's one of the application. That's one of the application of Pythagoras theorem in this way. Let's move fast. For the next, I said why the triangle formula is. I think have we not talked about it? Okay, I think yeah. So let's talk about this. So why the triangle formula is half a triangle. Half a triangle because I'm sure many of us know that the area of a triangle is half base times height. We don't know how the formula was actually how it actually came about. Do you understand? If you are to look at it now, if you are to look at it, can we hello while I was while I was explaining Samuel, Samuel, while I was explaining this stuff, can you see while I was putting my cursor on my slide, can you see my cursor? While I was pointing on the shapes, you can see like let me explain. Can you see my cursor? Like this. You're able to okay. Nice. All right. So now majority of us don't know how the formula came about. So the way the formula came about was if you are to look at it, if you have to draw a perfect triangle, let me explain this because of our time. We only have 15 minutes to go. So let me do justice to my time very well. So I told you, see, if what you've learned today is how to think, is how to start thinking like um is how to start thinking logically, honestly, is enough for you today. Because that insight will actually make you have a deep thought and start reasoning about everything you see mathematically. Do you understand? So mathematics is not always about cramming. In fact, majority of mathematics aspect is all about understanding. You understand? So now look at it. Let me present this. Oh, okay. Stop sharing. Okay. I'll just stage. So for the formula, now you know I said something the other time. Okay, let's see. Do I have a triangle shape here? Okay. Um, I'm trying to pick a triangle here. Okay. Yeah. So for this triangle now, look at it. If I had to look at it, I said the area of this triangle is 1/2 times base, half base times height. Now, half base times height. What I was talking about is how this formula came to existence. It came to existence by understanding that if we actually split this triangle, if you actually split this triangle into two, you can see it will bring about this right angle triangle. Look at it though. It will bring about this right angle triangle. And if you are dealing with this right angle triangle, now you have see, it has split into two. If you pick one out of it, this is it. This is half of this base. This is half of this base. Then the height. Do you understand? So half base times height will actually give you area of this shape. Do you understand? Following that, knowing fully well that if you divide um this triangle into two, you have your height, and then this part are the what, the base. So that gives you, okay, sorry. So that gives you the um understanding that the formula is half base times height. Um, let's relax. Let's relax. I don't want us to. I don't want us to put pressure on ourselves, because um I want us to digest what we have done so far. What I've explained, especially the aspect of we talking about the struggles, talking about the hook, the trap, the discovery, the application, the arena. I want you just to think very well about that aspect, understand, and see how you can apply it um in your reasoning while you're dealing with mathematics and every other subject too. So, okay, moving on to next slide. Coming up. Okay, I think I've spoken about this. Okay, let me present my slide. Okay, let me stop this. Mm, okay, this is was what I explained the other time. Said there are 50 pairs. If you are adding up numbers, if you are summing up numbers from 1 to 100. So now, what if I ask you now, if you are smart, because this is one of the work, this is one of the assignment I want to give to us. For girls the other time to think about adding numbers from 1 to 100, adding numbers from 1 to 100, and getting 5,050 using a particular logic. If you want to use the same logic you used by telling you to find the sum of numbers from 1 to 200, can you actually do it? Do you know how to solve it? Does it make sense to you? Because if you have to check, if you have to say 201, 01, 199 and 2. I don't know. I've already said the answer, but if you have to use that method, do you think you get the same answer as what I explained before? So let's try that and see. Moving on to the next slide, because we have, by my time here, we have 10 minutes. We have exactly 10 minutes. Yeah, by my time here. So and I will use 5 minutes, and I'll use 5 minutes to explain this, and use the remaining 5 minutes to um talk about the aspect of this program and what we should expect more, because this is just an intro to what we have for us. This is actually an intro. There are a lot of things in impact for us, and you don't forget, this program is for mathematics based and also for coding logic. So there are a lot of things. So if you are watching, if you're in this live and you're watching me, hearing me now, always please have the mindset to expect a lot from this program, and please inform your friends. Okay, don't let me divert. Um let me quickly explain um 2 slides from this. Let me explain some other things that I have here. So now, it said 2 players bet on a coin flip. Let's see. Honestly, I did not even spend time on this slide, but let's look at it. 2 players bet on a coin flip. One always call heads, one always call tail. Is this fair? Hmm. Hmm. Two players bet on a coin flip. One always calls head, one always calls tail. Is this fair? So now look at it. You will discover that symmetry, not feeling, determines the fairness. Then you investigate the dice cards, a Nigerian market problem involved. Okay. Hmm. Define the probability as favorable outcome. Alpha. I didn't even check this slide. Oh, to your law. Alpha. I say I didn't even check. I round up at me. I didn't even check this aspect. I just feel like I will use logic. Okay. Okay, so like I said before, because of our time, there are a lot of things that impact for us um on this program, and I will want us to not just take this for granted. Don't feel like it's a free program. It's a program that it's a class that you would not want to take serious because it is cheaper. Because honestly, this is one of the cheapest avenue we can get. And if as for our age, I feel like it's not even like I feel like the best advice I can give to us is to take opportunities um very fast, take opportunities seriously as they come, grab them because there are lots, So we'll continue this. We'll continue from this aspect in the next class. We'll continue from this slide that I stopped. Basically, don't forget everything I've said. Think logically, observe, notice, and apply. And then you will notice that you are having improvement in your reasoning. Thank you so much for your time today. I really do appreciate our patience in listening today. Thank you so much. Thank you so much. God bless you.
My boss.
Ah, Alpha.
I did, Joe.
Guy,
I know
wait
say
till they talk.
I know say now because you don't really get time. Look the slide
Oh,
like that.
guy, I don't get time. See, I never see that slide. Sef. You know, say I told you say I dey go somewhere that time.
Mm.
That this that time I know sincerely I checked the slide till like maybe half of the you know say you just send me the new one. Like I'm now actually getting some of this stuff now. Say now that I'm looking at probability aspect. Okay, maybe next what's the plan now? There will be more preparation. Maybe it has ended now. Yours has ended.
Let me end this one.
Abi.
Yeah.